In this video, we're going to be taking a look at 2.1, which is Drawing Wumps. But let's go ahead and first look at the introduction to this particular investigation, and we're focusing on similar figures. Right, so we talk about similar figures a lot when it comes to computers because there's lots of shapes that can be easily expanded or contracted to be bigger and smaller, but we're still using those similar figures. They're similar because they're the same shape, not necessarily the same size. So keep those things in mind as you look through this. This is our big overarching story for this investigation, is taking these shapes and enlarging them, reducing them, stretching them, pulling on them on a coordinate grid. So you will definitely need graph paper for this investigation. And so if we look down here in the did you know that you can make these figures on a computer, like if you ever used Microsoft Word, you've taken figures like this and you've made them bigger or smaller. Let's take this guy for example. Right here I just clipped and copied this guy from this guy over here, but you notice we can pull here, make him a lot bigger of his former self. We can make him a lot smaller of his former self, or we can make him about the same size. We could also, so that these are all similar figures to him. You see how they're similar, same shape, same size. Their sides and perimeters are different, but all of their side angles are the same. Now we could, and what we're going to be doing in this section is pulling horizontally. What happens now? Well, they're no longer similar, right? Then what if we pull him this way? Well, those are no longer similar. They're really not even, they're the same shape, but they're not similar because proportionally they're different. Okay, so we're going to be doing stuff like this to some of these shapes in this particular investigation. So if we start off 2.1, remember we have to understand the story behind what we're doing because it all ties into a singular problem that we're investigating in, and this is drawing these things called wumps. I know that's a silly name, but that's what we're going to call them. It's the family of wumps. And these family of wumps, they should be similar to each other. All right, and so the first thing that you're going to do, I'm going to come down here. And on this first one, Marta tries several rules for transforming mugs to different sizes. So mug is one of the family members. So at first glance, all the new characters look like mug. They look like they might be mathematically similar, and mathematically similar meaning all of the side lengths are similar or proportional to each other. So if one side length gets twice as big, all of the side lengths get twice as big. Otherwise it's stretched horizontally or stretched vertically. It'll look really fat or wide or skinny and tall. So some of the new characters are quite different. Okay, so on this first one, refer to the mug, wump, and column in the table. So for parts 1 through 3, plot them in order, connect them as you go along. For part 4, plot 2 points. So here's what it looks like. You should have your lab sheet, or you can print it off from my website, which looks like this. Okay, these are all the points that you are going to sketch. So these are the first part. These you're all going to connect together. So from here to here to here to here, you're going to connect the dots as you put them on your graph paper. Then you're going to stop and you're going to do the same thing with these. This gets connected to this, gets connected to this, and so forth. And then with these, and then you notice these last two, these are just individual dots. So make a dot there and make a dot there. A couple things that you have to remember is these coordinates are always given as x, y. And x is your horizontal, and y is your vertical. Okay, so always be aware that the x is a horizontal, it comes first, the y is a vertical, it comes next. Now let's take a look at preparing our graph paper. So you're going to need a lot of space. So what I would do is I would use the entire length of your graph paper here, and I would go ahead and make my axes. So give yourself a little bit of space. So go all the way down the length and then go all the way over the width, trying to make a line as straight as you can. label this as your y-axis and this as your x-axis. Now we're going to be using those points in the table. So I have the table right here next to me. So the first point in the mug wump, I'll go back to it just really quick. I'm graphing these points right here. So I'm graphing these points right here, and I start with 0, 1, then 2, 1. So that's what I'm doing. So at 0, 1, so that tells me that I don't go left or right, I just go up 1. That's going to be right there. Let's do this in red. So that is 0, 1, and then 2, 1 means I go over 1, 2, and then I go up 1. Then I connect those. And then 2, 0 is going to be right there, and I connect those. And then 3, 0 is going to be right there, connect those. 3, 1 right there. And then if I keep going, then 5, 1. So this is 1, 2, 3, 4, 5, 1 right there. Connect those. 5, 0 is the next one. And then you just keep going because the next one's going to be over here, here. And then go ahead and finish this out. You just have a few more to do for points A through M. Finish this out and then come back to the video to see how you did. So when you finish that up, it should look something like this. And next, we're going to go ahead and plot points N, O, P, Q, and R on your table. Pause the video and come back when you're finished with that. So once you're done, it should look something like this. So this is mug. So label this guy, this is mug, that's what his name is, and that is the first in the wump family. Remember, we're looking at the wump family here, and if we come back to our table, we graph that first column. Next, we're going to go ahead and graph that second column for Zug. It's because if you look at part B out of your notes, it says use the columns for Zug, Lug, Bug, and Glug. So we're finding the coordinates for them. So for example, in Zug, let's look at Zug real quick. We'll do his in green. So there's a rule to find his coordinates. His are 2 times x and 2 times y. So you're taking each of these times 2. So let me erase some of this. So you're taking 0 times 2, that's 0. Then for the y's, you're multiplying by 2 as well. So 2 times 1, that's where the 2 comes from. 2 times 2, 4. 2 times 1, 2. Then the next one would be 2 times 2, that's also 4. 2 times 0, that's 0. And again, I'm multiplying by 2 because up here, you notice both of these, the x and the y, are being multiplied by 2. So if we keep going, 2 times 3, that's 6. 2 times 0, that's 0. Go ahead and pause the video and finish up that column. All the way down to the very end right here. Okay, so for Zug, this is your column right here for Zug. Go ahead and check your answers on all of these. Make sure that it's accurate. Pause the video kind of as you need to, but you're just multiplying all of Mug's coordinates by 2. Everything's being doubled. Okay, and then we're going to do that for the rest of them. So if you wanted to go ahead and graph Zug, you're going to go ahead and graph Zug. You can do it on the same coordinate plane as we did here. So Zug, since you're multiplying all of his points by 2, he's going to be twice as big. Okay, his side lengths are going to be twice as big, twice as long. So go ahead and graph him, or you can finish out these if you're on a roll. So let's take a look at Zug. Let's do his in purple. Okay, so with Zug, we're multiplying by 3. So now we're taking all of these and multiplying by 3. So just your x's right now. So all of these and multiplying by 3. So 0 times 3 is 0. 2 times 3 is 6. 3 times 2 is 6. 3 times 3 is 9. So we're going to go ahead and multiply all the x's by 3. So that would be 9, that would be 15, and so forth. You get it. And now all the y's are staying the same. So these are going to remain the same because you're not multiplying the y by anything. So it'd just be 1, 1, 0, 0, 1, 1, and so forth. Go ahead and finish up that column. Go the rest of the way, all the way down to the bottom. And do the rest for bug. You notice for bug, that first one is already being multiplied by 3. So to keep it simple, right, think smarter, not harder, since we already did that math here, all of these multiplied by 3, you can just kind of copy over. So you know that all of these are going to be the same. So it's going to be 0, 6, 6, 9, 9, 15, and so forth. Okay? And then you're going to be taking the y values and multiplying by 3. So it's going to be 3 times 1, 3 times 1, 3 times 0, 3 times 0, 3 times 1, 3 times 1, and so forth. Now with glug, the last one, this person is a mix of lug and bug, okay? Well, kind of, I guess, because this first one is just multiplied by x, so all of those x's are going to be the same as what we see back here. So let's use yet a different color. All right, so you notice this is 0. This is going to be 0. 2, 2, 3, 2, 2, 3. All right, none of those x's are changing, but all of the y's are changing by a factor of 3, which we already did back here. So it's just going to be 3, 3, 0, 0, 3, 3, so forth. And you're going to keep going. So go ahead and finish up all of your tables and then come back and see how you did. Okay, so here's the tables and what they should look like. If you need to pause the video, pause the video. You have access to all of this via my website. But go ahead and make sure that you're doing these right, because it's very important that all of your points are accurate. Again, it's not difficult. It's not hard math. It's not difficult by any means. However, it does require some not tedious even, it's not hard, but just a lot of work there to get those points. Now, once you have all of those points, go ahead and plot them on the graph that we started plotting our first one, mug on, which would be, it looked like this. Go ahead and plot the other ones on there. If you want to use different graph paper, that's fine. You'll need a lot of space because the other ones get pretty big. Go ahead and do all of that and then come back to the video. So here's what a lot of them will look like. So we don't have them all on the same. I'd recommend doing on the same because it's hard to tell here. But mug is actually a lot smaller than zug, right? So he goes from 0 to 6 is how tall he is, or actually 7. And you notice that zug is going to be twice as big. Because if each of Zug's sides were multiplied by 2, his sides are going to be twice as long, he's going to be twice as tall, his perimeter is going to be twice as big. But down here with lug, you notice you only multiply the x's by 3, and that stretched him horizontally because x's is your horizontal change this way and that way. Let me do this real quick. There we go. Okay. So you only changed him horizontally, so it's only a change this way. Okay, up and down it stayed the same because you didn't end up multiplying by anything, because remember this was 3xy. That was the change where y stayed the same, but the x got 3 times wider. Now with bug, right here, what's going on here? There you go. Now with bug, his was 3x, 3y. Now you multiply by 3 on both of them. So that makes bug 3 times as large all around. 3 times the perimeter, 3 times the side lengths, and he is still similar because he's proportional. Lug, he doesn't look similar. He's way too wide to be part of this family. And then for the last one with glug, this is the one where you multiplied x by nothing. You kept x the same. So glug is just as wide as his brother Zug or Mug, but he's 3 times taller because of that factor of 3. And so at this point, we've answered all of A, all of B, because you were supposed to draw them on part B. Okay, now part C, you're comparing, talking about that we already did a little bit, but go ahead and compare them, which are imposters. Now, imposters are if they are not similar, meaning they're stretched too wide, stretched too tall, and it always comes back to Mug. So everybody's got to look like Mug and his family. Go ahead and answer part C and then come back and we'll talk about it. So if we're looking at all of these, if you're looking again through the lens of Mug, that is the original family member. Right here, you're looking through the lens of Mug. Which of these are imposters? Well, Lug is definitely an imposter, and this guy up here, forget his name, is definitely an imposter. Which one is he? Oh, Glug. That's Glug. He was definitely an imposter, right? Because Lug was 3 times wider than he is tall, and then Glug was 3 times taller than he is wide. Those are the imposters. And then what things are the same about Mug and the others? Well, they're the same shape in a way, right? But Lug, I don't know if we could say that Lug and Glug are the same shape because they're disproportionate, right? They are similar shapes in that they're not proportionate, but we could not say that they are similar. And then what are they different? Well, they're different sizes. Even though Mug and Zug and Mug and Bug are different sizes. So Bug is 20 units tall, where Mug is only 7. So this is 21 actually, and this is only 7. They are not the same size, but they're similar to each other. Okay, and you can see what the book answers are, but use your own words to make sure that you are understanding what you're doing. And that is all that I have for 2.1 Drawing Wumps.